Hello students, welcome once again. I want to take you another topic, another question on, try to treat another question on Cycloid. Let me call this Cycloid 2. Now, this is a question, an exercise. A circle of 60 mm diameter rolls along a straight line without slipping. Draw a curve, trace out with a point P on the circumference for one complete revolution of circle. Draw the tangent to the curve at the point on it, 40 mm from the line. Now, when you see a question and it said a circle of diameter rolls along a straight line without slipping, you should know that it's a circle, a cycloid. In case you are asked to name it, then you name it cycloid. Now, but let's start with the question. 60 diameter. Now, you pick your ruler and you measure 60 mm, that is 30 radius. 30 mm radius. This is 1, 2, and you have 30 exactly on 4. So you can confirm over here. That's correct. So you measure out your 30 on this by drawing your circle. You can see. Then you divide this into 12 equal parts or 8 equal parts. This is the center point. I'm trying to set my T-square. Now I can have a straight line. Use your set square to divide. Should I use your set square or use your compass? And from there, you continue to divide into 8 equal parts, and divide into 40. Let's use 8 equal parts. In the last tutorial, I used 12 equal parts. Now you can actually number it from this side. It should be 1, 0, 1, 2, 3, 4, 5, 6, and 7. Then you project out this line, this center line. You come back, all these lines, you project out this line too. You project out this line too. So you measure this your radius that you have over here. Huh? Can you see that? And you use that to cut out one, two, three, 4, 5, 6, 7, and 8. So you have this 0, 1, 2, 3, 4, 5, 6, 7. The next one should be 8 and 8. 8 is somewhere there. So the next thing you do now is to divide those lines up. First, you bring them up using your set square. Now, after doing that, you trace out this line one by one. This 7 and 1. So the next thing you show from this your point is your P, and this last point which you have here is your last point P. This is where the circle must stop. Now if it rolls, you assume it rolls. So you assume this place as your CO, This is C1, this is C2, C3, C4, C5, 6, 6, 7, and 6, 8. So if your circle, if this circle moves and rolls, you have 8 circles. So the first point in which it will touch a line is this, and the second point I'll show you as you measure using this radius. You draw the second point, you show where it touches the line, as if you are drawing this circle this way. So the second point which it touches this line is here. That is for your line 2. I don't want to draw the circle so that I won't confuse you, or some of you don't understand in the first video. So then the third point, which is C2, is this point, and you draw it again. You mark it out as if you are drawing a circle again. So this point is the third point. The fourth point, you confirm the radius again. You come to this point. That is 3. The third point in which you draw your circle out is this point. You can see where it's touching. You mark that point. This is the third point. Now the fourth point, after confirming your radius, you come to point 4 and you draw another circle. So that's the essence of those circles. You see where it's touching? That point, this point is the fourth point. You confirm your radius again to see if it is correct. You come over here. The fifth point, where it will touch this arc, this point is the fifth point. You note this and you confirm your radius again. Then you go to the sixth point. The sixth point, and you draw. You see, this point is the sixth point. So you confirm your radius again. You confirm your radius again from this point. See, you check. You come to point 7. This is point 7. That is center circle 7. You draw your arc. You have to be careful. This point you have here is your 7th point. This point. Then you confirm again to have your 8th point. At your point 8 here, you draw. So you discover that it meets at this last point. That where you have this P. That is where your 8 to touch this last point, this P point. So this point is your 8th point. That's the last radius. So, and therefore you now join the circle together using your French curve, or you can use your flexible curve. It depends. and you keep joining. Now that is how you draw your cycloid. But you are told to actually, because this point is the last point, which you have your in which when I want to show that last point, the circle would have been something like this. The last circle would have been something like this. Now, so you want to show your tangent. So draw a tangent to the curve at a point on it 45 mm from the line. You can either draw from this point or you draw from this point. Now, what do? You can take a reference for, you said it's 45, so you have to measure out from this point to this point is 30. Now, from this point you measure 45. So this is 10, 20, this should be 45. That's 45 mm. You can cross check with your t-square. You cross check, you discover that this is 45. So this is 45, as you can see on your t-square. This is 45. So you use that, you bring it to this point. You see how you take it from this side, and you note that point, which is this point. You can either draw it this way, or you come over here and take it from this point, and you note this point, which is your 45. So if you know that, you will draw this line, that point 45, to touch your curve. If you are drawing from this point, it's touching this. Now, then at this point, you are going to take your compass and measure out this radius, which is 30, the radius you use for your circle. And at this point, when it is touching, this is your R, you use it to make a curve, which is going to touch this circle at a point. So this point, you join this point, let's call it A, you join it to your baseline. So then this point, which is your M, you are going to join it to this R. Now you have to draw a perpendicular line to this one, and that will be your tangent, because your tangent is just perpendicular to this. Your tangent should be perpendicular to this. So should be at an angle of 90 to this. Let me do it this way. So this is your tangent you have drawn to this curve. You can do that same thing over here, and you come over here, the same thing. You have measured, you showed your 45. This is 45. Then you draw it to touch the curve. So it has touched the curve. Over here, you measure your 30. At this point where you touch the curve, you can call it your Q. You measure your 30. Your 30 is touching the line over here, and you join it down. So I've joined it down, then you connect that point, this point J, you connect it to Q. Sorry. Then you draw a perpendicular to Q. You can draw your line, a tangent, perpendicular distance to Q. It must be at angle 90 to Q. You draw a perpendicular this way. You draw a perpendicular line. So this is your perpendicular line. Then your tangent. So you discover that the both tangents, they may likely meet. But you were asked to draw one, not two. So what you're supposed to do, I'm just trying to explain better. What you're supposed to do is either you draw this, you show at this point, or you show at this point. So that's the end of the class. So you have answered the question. Draw the tangent to the curve at a point on it, 45. These are the points on it, 45 from the line. So, and then that is for this. Thank you.